Okay, algebra students, so our learning target for this video is I can find the length of hypotenuse of a right triangle when given the length of the other two sides. So here's a little bit of a reminder. In a right triangle with the legs A and B and the hypotenuse C, a squared plus b squared equals c squared. This is the formula we're going to use to find our missing side length. And today, that missing side length we're going to find and focus on is just the hypotenuse, which is this longest side that's opposite of the right angle. So if you look at this spot right here, you'll notice that there's this little square in the corner. That indicates to us that this is a right triangle because that's a 90-degree angle, and the hypotenuse is the side that does not touch that right angle. So we are going to be given A and B in these examples, and we're going to have to find the value using this formula, the Pythagorean theorem. So let's go ahead and try it. It says find the length of the hypotenuse. So we are, first I'm going to write down the Pythagorean theorem again because it's kind of easiest if we have a visual, and then I can just substitute in the values I know for the variables that they go with. So I'm finding this side that does not have a length. Oops, excuse me. I'm going to highlight that. So I'm going to find this side, and that side we're going to call C. But we know that the two legs have to be A and B. It doesn't matter. Those are interchangeable. So I could have put the A next to the 5 and the B next to the 2. It doesn't really matter. So I'm going to go ahead and rewrite this formula, but I'm going to substitute in the values that I know. So I know that A is 2, so I have 2 squared plus 5 squared equals C squared. And now I'm going to simplify this. So 2 times 2 is 4, plus 5 times 5 is 25. That has to equal C squared. So 4 plus 25 is 29 equals C squared. So if I want to get C by itself, I have to get rid of this exponent. And how do I undo an exponent to the power of 2? We've talked about this before, probably a long time ago, but the inverse operation, sometimes we say opposite operation, but it's the inverse operation of taking something times itself or squaring it is taking the square root of it. So I'm going to take the square root, and I'm going to go ahead and change my color. So I'm going to take the square root of 29, and that, if I do it to both sides, it's just like when I multiply both sides by something or divide both sides by something. When I take the square root of both sides, this squared and the square root cancel each other out. Just like when we're solving, we do, if it says divided by 4, to undo that division, we multiply. If I want to undo that exponent to the power of 2, I'm going to take the square root of it. And so all I'm left with on the right side is just the letter C, which is what I want. And then the square root of 29 is actually a possible answer for this problem. So the square root of 29 is what we call an exact answer. But if I wanted to give the approximate answer, I would take my calculator, and I know it's going to be close to 5. It's going to be a little bit bigger than 5 because 5 times 5 is 25. So the square root of 25 is 5. So if I take a calculator and I do the square root, even the calculator on your phone has the square root sign, the square root of 29 gives me a really long number, but if I'm going to round it, it would be about 5.4. So if I wanted to write this at the end, I would write C is about 5.4. That little, like the equal sign that I have a little wavy, that means about 5.4. So we're going to go ahead and do another one. If you're like, whoa, I don't understand. It's okay. We're going to do another one. Here we go. So it says, let's try it. Find the length of the hypotenuse. Now this, you'll notice this triangle is turned on its side, but the side that's opposite of the right angle is always the hypotenuse. So here's my right angle. I circle in a red highlighter. And here is the side I'm trying to find, C, because it does not touch that right angle. So again, I'm going to start with writing a squared plus b squared equals c squared. I already labeled my c, so I have a and b. I'm going to go ahead and plug those values into my formula. 3 squared plus 6 squared equals c squared. Now I have 9 plus 36 equals c squared. If you need to use a calculator for that part, that's okay. 9 plus 36 is 45 equals c squared. Some students stop here and I can't give them points for it because the side is not 45. That would be way too long, right? If one side is 6 and the other side is 3, there's no way the side could be 45. We have to get rid of that exponent that's with the letter c. So we're thinking what number times itself would give me 45? Well, in my head, I'm thinking of a number. I know that 6 times 6 is 36. And I know 7 times 7 is 49, which is really close to 45. But it's going to be somewhere between 6 and 7. So I'm going to go ahead and take the square root of both sides. The square root of 45 has to equal the square root of c squared because I'm doing the same thing on both sides, just like when I was solving equations. Now my square root and my exponent to the power of 2 cancel out. I'm left with c over here. And the square root of 45, I could leave it as the square root of 45, which would be the exact answer, or I can write 6.7. But that's not an exact answer. So if I was going to write this, I should write c is equal to about 6.7. All right, so we're going to do one more here. Oh, just kidding. Okay, no, I think we have 2 more. So it says find the length of the hypotenuse. So they call this one x. We already know that it's the hypotenuse. We call it c. But we can just go ahead and start a squared plus b squared equals c squared. You could write x squared. It doesn't really matter, but we're just going to stick with this. So I'm going to skip those steps I was doing before because now I'm getting really comfortable. I know I can just plug those 2 values in. 4 squared plus 3 squared equals c squared. 4 times 4 is 16 plus 3 times 3 is 9 equals c squared. 25 equals c squared. That's a 25. Sorry, doesn't look like a 5. There we go. 25 equals c squared. Well, I know that 5 times 5 equals 25. So I already know that c equals 5. But if you don't know that for sure, what you can do, take the square root of both sides. These cancel. In my calculator, if I take the square root of 25, I would get c equals 5. If you really wanted to be exact, you could write x equals 5 at the end. Since up here they called this x, it doesn't really matter. All right, so last one. It says find the length of the hypotenuse of a right triangle with the side lengths of 6.5 and 9. It's going to be the same thing even though I gave you a number with a decimal. You could sketch a little picture if you wanted, or you could just label the numbers a and b. Either way. A, we're going to call that B, and we're trying to find this side, which is C. So we're going to go ahead and plug it into our Pythagorean theorem. So 6.5 squared, I'm going to need a calculator for this one, plus 9 squared equals C squared. So 6.5 times 6.5 equals 42.25. 9 times 9 is 81 equals c squared. So 42.25 plus 81. Go ahead and move this up. This side equals 123.25 equals c squared. So again, this is the hardest step, is this last step here to get rid of this squared on the c, because we just want to know what c equals. We don't want to know what c squared equals. We're going to take the square root of both sides. These get to cancel out because those are opposite or inverse operations of each other. And I'm left with 100. If I take my calculator and do the square root of 123.25, I get about 11.1. And that's rounded, but that would be my answer. All right, so thank you so much for watching. Thank you so much for trying your best. We'll practice this together, so don't you worry about it. It's going to be a lot of fun.